In this class, we're going to consider how you factorise a quadratic expression, which is in the format of a trinomial. So remember, a trinomial is what this guy and this guy, well, all of these guys are, but in general, a trinomial is in the format ax squared plus bx plus c. So that's your standard quadratic expression, and this one happens to be in trinomial format. If you drop off the number on the end, then you've got like a binomial, and there's various variations on that, but the trinomial preserves all three terms. So we want to figure out how can we factorise trinomials into two brackets. So trinomials always factorise into two brackets. Well, the best way to start this is by thinking of the reverse process. So we're going to want to put this guy here into two brackets like this. Let's actually consider what happens if you've got two brackets and you multiply out those brackets. Knowing how that works, so kind of the backwards reverse process of what we're going to look at, is actually the key to being able to do what we're going to do. So let's say you've got the two brackets, x plus 2, x plus 3. So we're going to multiply these brackets together. Sometimes this is called FOIL, like the acronym. So like first, outer, inner, last. Or there's various different acronyms for reminding you how to multiply these out. But when you do this, it's basically x times x to give you an x squared. You get a 2x, you get a 3x, and you get a 3 times a 2 to give you a 6. And then we take a second line of work in to combine the two middle terms. So 2x plus 3x gives you 5x plus 6. So you end up with a trinomial. So when you multiply out two brackets, you end up with a trinomial. But the important thing is, for our technique, that these two numbers here, or these two terms here, have combined to make that term. Okay, that's going to be key. That's the thing that bridges the gap between this 4-term expression and this 3-term trinomial. So if you notice that essentially what we've done there, imagining we're starting at this point, is to take these two numbers and multiply them to give you this, and take these two numbers and combine them to give you this. So if we're going backwards, then we need two numbers that multiply to make that number, but combine to make that number. So when we look at this example, we know that to make the x squared is going to have to be an x and an x, because that's the only possibility. You could put the x here, in here, or here and here, but the standard convention is to put it here and here. So if you see an x squared, just an x squared, not like a 2x squared or any other number, but just an x squared, just go straight to putting in your x and your x. That's a no-brainer. That's going to happen every time. And a lot of the trinomials will have just a 1x squared term. So you can get to that point just as a no-brainer. So then the difficult part, basically, we need two numbers, one that goes here, one that goes here, that times together, multiply together to make 12, but they've got to combine to make an 8. So thinking about the factors of 12, remember these have to be whole numbers. So it could be a 12 and a 1, it could be a 4 and a 3, or it could be a 6 and a 2. But we need the combination, like we have the combination here, to make an 8. So a 12 and a 1 cannot make an 8, a 4 and a 3 cannot make an 8, 6 and a 2 does make an 8, so that tells us it's a 6 and a 2, and that's how we go about these. In this case, it's a positive and a positive, which is the easiest scenario, and we just go plus plus. If we multiply that bracket out, so doing this process here, we'd get x times x to give x squared, 6 times 2 gives 12, that would give you a 6x by the combination of those two, and a 2x, 6 and 2x gives you 8x. So we really are literally just kind of doing this process in reverse and kind of almost doing this step in our head. Okay, right, so scooting on to the next example. Also a fairly straightforward one. So x and an x, we need two numbers that make an 8 when you multiply them and combine to make a 6. That's going to be a 4 and a 2. The only other option would be an 8 and a 1 to make the 8, but an 8 and a 1 cannot be used to make a 6. So x times x to give you x squared, 4x and 2x give you 6x, and 4 times 2 gives you 8. These are difficult. Most students find these very challenging at first. They take experience more than anything else. But once you've done a few of them, you'll start to see a lot of the same numbers, and in your head you'll already be thinking, oh yeah, I know the factors of 8, that's 8 and 1 and 4 and 2, and you'll just start to get a feel for how the numbers work. Slightly more difficult example, this third one, because it's got the negatives, but we're going to go through the same process. Because it's a 1x squared, that tells us we can go straight to putting in our x and our x. Now we've got to think about the 15. Don't worry too much about it being a minus 15 initially. Just think, right, it's a 15. That could be a 15 and a 1 or a 5 and a 3. Those are my only two options. I need to combine those numbers to make a 2. 15 and 1, definitely can't combine those to make a 2. Tells us it has to be a 5 and a 3. We can just go ahead and put those in. Doesn't even matter where you put them. I could have put 2, 6 instead of 6, 2, 2, 4. The order, when it's an x squared only, the order doesn't matter. For this guy here, it does matter. We're going to chat a little about this one in a moment. So we've got our 5 and our 3. We know that theoretically a 5 and a 3 can make a 2 or a minus 2. So we just need to get the plus and the minus correct. This is the difficult thing. This is what takes a lot more practice than, say, these two. If you're going to make a minus 15 by multiplying these two numbers, then to make a minus, a negative number, by multiplication, one has to be positive and one has to be negative. So it's either plus minus or minus plus. We've got to decide which of those by using the middle number. We're trying to make a minus 2. So if you had plus 5 and minus 3, positive 5 minus 3 is positive 2, but we want minus 2. So it must be minus 5 and plus 3. And that still gives you 1 minus and 1 plus, which multiply to make the minus 15. So that would be that one. So that guy there is definitely a level above these two here. These are your starting point. Probably initially, all of the questions you'll work will have a positive and a positive. Then you'll maybe get a positive and a negative, or two negatives. You can have all of those possible combinations. Right, let's look at another example. I'm not going to finish this one off. I'm just going to set this one up. It's slightly more, well, it's way more difficult actually when you've got a number in front of the x squared term, but it's only slightly more difficult in the sense that the process doesn't really massively change. To make a 2x squared as opposed to an x squared, we just need to put a 2x in an x. X times x gives you x squared, 2x times x gives you 2x squared. So that's all we do to modify that arrangement. The bigger challenge lies in getting the middle, well, the other numbers basically, because whatever you put here and here, yeah, they've got to times together to make a 3, and they've got to combine all together to make the 7. But when you're doing FOIL, when you're multiplying out, remember that as part of the FOIL, these two numbers multiply together, or these two terms multiply together. So that means that whatever we decide to put here is going to multiply to the 2x. In other words, it's going to get doubled. So it's not like here when I said 6x plus 2x gives you 8x. This time it's going to be these two multiplying plus the combination of these two, but this number here is getting doubled. So it requires quite a bit more thought. And this is quite an easy one actually, because 3 is a prime number, which means that the only factors are a 1 and a 3. So it's either 1, 3 or 3, 1, and it's plus, plus, which means it will definitely have to be a plus and a plus here. When you get to more difficult combinations, you might have a plus minus or even two minuses here, which is far more challenging and requires a bit more instruction from me and also a bit more practice as well. So we're just going to park that one and leave it. This was really just to show you how to handle most of these trinomials, but you will eventually get to the point where you're ready to take on these more complex forms as well. So if that makes sense to you, then just move on to trying a few practice questions of these types. You could have a go at some of these if you've got some practice questions to work on. If you're not quite ready for those, then just leave that for now. Focus on these guys and then they'll be waiting for you in the future.